In this video, we are going to install the PiTrac software and its dependencies into our PiTrac system, perform some configuration, and do a few initial tests. At this point of your build, you should already have the basic PiTrac enclosure and physical parts of the system built. The Pi 5, the cameras, the connector board should all be wired up and installed on the tower. You should have your power supply connected and working. You should have an SD card flashed with whatever the current Pi operating system is. In this case, we are going to be using the Trixie version of the Pi operating system. If you have a monitor, keyboard, and mouse connected to your Pi, that's useful for debugging, especially if for some reason it isn't booting and you can't get connected to it. You can more easily see what's going on. To begin, we're going to start by opening up the PiTrac documentation site. This is at on GitHub, pitraclm.github.io/PiTrac. And we want to make sure when anyone's working on the project that, if at all possible, they're following along with the documentation. That way, if there's problems in the documentation or discrepancies between one of these videos and the documentation, we can fix whatever we need to fix, and hopefully the next person who comes along doesn't have to experience that, whatever that problem is. The correct place to start for a build where you're going to actually pull the code onto your PiTrac, which is what a lot of folks will do, is at this URL right here. This is the Express Path setup. It's set up for experienced users who have some knowledge of Linux, and it allows you to actually pull down the code, which means you can then modify that code, work out problems if you need to. A second way of downloading the code is simply to install the package. There, though, you just basically get the executables and you don't have the actual code, source code. So I've opened up a command window. This is under Windows, so I can run some command line utilities. Now, what we've done is we have already set up the Raspberry Pi in the sense that we've created an SD card, which is described here by using the Raspberry Pi Manager. We put the card in the Pi, and we powered the Pi on, and when we set up that SD card, we also gave the Pi a name, and we told it what wireless network to use. We also hooked it up to a wired network, so we have a lot of confidence that we should be able to, assuming it came up correctly, we should be able to log into it. I've actually confirmed that by hooking up a monitor and a keyboard and a mouse to the Pi directly, and I can see that it's come up correctly and that it's on the network. But you wouldn't necessarily have to do that. You could also simply follow these directions and log in remotely. There's two ways of logging in. And of course, you will have enabled SSH. That's the first way. So I should be able to say SSH and then the name of my Raspberry Pi, which in this case is RSP11. Now, sometimes you will type in a command like this, and for whatever reason your network may have not yet picked up that there is a device called RSP11 or whatever you've named your Pi. If that happens, I'll give an example here of a non-existent Raspberry Pi. What will happen is the SSH will resolve, it won't be able to resolve the host name and will time out in a moment. If that happens, you would be able to still get to the device by giving it the specific network address on your network. In this case, my Pi is at 64. If you need to figure out how to do that on your Pi and you're having a problem reaching it, if you have a console, or sorry, if you have a monitor and a keyboard hooked up, you can do something like this on the Pi, not here in a Windows command prompt, and this will tell you what the IP address is. Now, my Pi should already be known by my network, so I'm going to SSH, which is secure shell, into the Pi. And this is the login remotely over here in the instructions. As it says, you can use the IP address directly if necessary. And what I have over here on the right is a Windows command prompt, you can get that by just typing in the letters CMD, which is short for command, in the Windows search bar, and it should bring up a command prompt like this. So, and SSH Secure Shell should already be installed on most Windows machines, and certainly almost all Mac machines. If it's not, you can find it online. The first time you log in to a Pi, the Secure Shell program will say, hey, are you sure you really want to do this? You haven't done it before. Just type in YES and it won't ask you again. So now, even though this is a Windows command prompt, I'm actually logging into the Pi remotely. Now, unfortunately, the Pi that I'm logging into doesn't actually have a MLEAR username. I set up a username called PiTrac. So in order to do that, you would, if you want to log into a different username, what you can do is, I'm going to push the right up arrow here. You can say secure shell into the device and then say -L and the name of the user on the Raspberry Pi that you want to log in as. So here I'm logging in as PiTrac. I'm going to type in my PiTrac password, which I set up when I built the SD card, which was right here. These are the settings you use when you create the little SD memory card that you're going to boot from on the Pi. So, having done that, having typed in my password here, I'm actually inside the Pi right now remotely. Now, I don't have a graphical user interface, but I can still do everything through the command line. For instance, ls will show me the directory, the subdirectories underneath my current working directory, which is home PiTrac. So let's continue on with the documentation. As it says here, the first couple of things we're going to do are to update the Pi before installing the PiTrac software. So I'm going to just I could hit this little copy button and then paste it directly into the Secure Shell session here. But that is going to run 3 commands, and I really only want to run one of these at a time because I want to see what's going on. So I'm going to run the first command, which is sudo apt, which is a package manager, -y, which says go ahead and upgrade or update and don't ask me each time. And the system will go through anything that needs to be updated. Now, I've just upgraded to the Trixie release of the Raspberry operating system, so there's not that many things that need to be updated because it's a brand new system. If you're running this on a later version of Trixie at some point in the future, you might have a lot more packages to update. Having now done that, I can say sudo -y upgrade, which will install these upgrades. So I have current, sudo apt upgrade. This could take anywhere from less than a minute to 5 minutes or so, depending how many packages are being updated. The reason for doing this is just to make sure that we are up to date and that we don't have any known bugs that have actually been fixed that are in our system. After we do this, we're going to have to reboot. Now that the upgrade is finished, I'm going to go back to our documentation. I'm going to select and then copy the next command, which is something you should get used to doing just because it'll save you some typing and the possibility of making a mistake. Even though I'm not copying this entire set of commands, I can still copy each individual command, come over to my Secure Shell session and right-click. That will paste the command that I just copied, which is a good habit to be able to do because you will save some time and it's less likely to you're less likely to make a mistake. So when I hit this reboot, the connection is going to go away because, of course, the machine is going down. So I'm now back in my DOS prompt, and the computer, the Raspberry Pi, is rebooting. That'll probably take about a minute or so. I waited a couple of minutes, so I am going to secure shell back into my PiTrac. If for some reason you try to log in too soon, it'll just say that it can't find the host or something like that. One thing I'm going to do before starting this, because I just created a new instance of my Raspberry Pi and PiTrac, is I just want to make certain that the cameras are connected. You can do that with the following command. This should show two cameras, 0 and 1. In this case, they are both monochrome cameras. These are Inamaker cameras. You can also test an image or two if you'd like to do that. This would be an example of creating a test image called cam0_test. This assumes you've already created a TMP directory underneath your home. When you run that, and if everything is working correctly and your cabling is correct, it should pause for a moment and then produce that file. You can do the same thing with what we call camera 2, which is actually in slot 1. So we're going to say camera 1 here in this RPI still command. This will correspond to camera 2. And at this point, once these files are created, you can either move the files to another machine where you can view them, or if you have a console that is hooked up to your Pi, you can just use the browser that comes with the Raspberry Pi GUI interface to look at the files. So now we're back in, we've upgraded our software, and the next thing the installation documentation tells us to do is to install the PiTrac software. Now there's a couple ways of doing that. If you don't want to be changing the source code and you want to do the absolute easiest way of installing PiTrac, you could simply use one of our pre-built packages. You would do something along the lines of apt install and then the name of the PiTrac package. But we actually want to install the code on the system because I suspect I might have to be making some changes. So instead we're actually going to install and compile the code on PiTrac, which is probably a good thing for most people to do. So step 2, what we're going to do is we secured shell back into our Pi. We're next going to clone the repository, and so I'm going to just select this command right here, use this little icon to copy it, and then in my command prompt I'm going to right click. So I'm going to copy the command here, and then in my secure shell session I can right click and those commands will be pasted right into the command line and the installation will start. The clone process probably takes about 5 minutes on most machines. This is just downloading all of the code, including all of the 3D models and the documentation for that matter, from the GitHub repository. So we're going to download everything onto our computer, onto our Raspberry Pi, and then, as you can see, the next step over here is going to be to actually then build that code. That's going to take care of installing everything that we need for the web server. It's going to take care of compiling the code. It's going to take care of configuring the machine for whatever cameras you happen to be using. And so we're going to do that next, but before we do that, I am going to do a couple of quick checks to make sure that, for example, our cameras are actually being seen by the operating system, and we'll do a couple of other checks as well. That's not in this documentation, although it may be in a future version. because the clone completed the command line that we copied into the console, then started the build. That's done by this line right here. You can also do this part first and then look around and then do this manually second, of course. I've done this enough times that it makes sense to just kick the whole thing off. What you're seeing here is the setup, configuration, and installation of a large number of software packages that are packages on which PiTrac depends. You can see here we're about 34% through the entire thing. In a moment after these packages are installed, you'll also see the PiTrac code start compiling. Right now you're seeing some of these packages that PiTrac relies on. You can see here there was an error on the installation. This shouldn't generally happen, but this is a brand new build that I'm working with. What you want to do is at the end of your at the end of the last command, and the last command was here, which is sudo build.shell dev. At the end of that command, you just want to scroll back and make sure you look for any errors. In this case, this is probably where the error started. If you see something like that, just go to the Discord server, probably go to the software channel or the support channel, and let folks know what you're seeing. Give them a cut and paste of the, you can just select something and copy it and then paste it directly into the Discord server, and hopefully someone should be able to get things fixed. Alright, we made a couple of fixes in some of the packages that are on the PiTrac GitHub repository, and I think at this point if we change directories into the PiTrac packaging folder and run our sudo build shell dev command again, this should work this time. Now you notice that this time everything seemed to work well. It says it's done, it's green, I didn't see any errors. Note that because the camera configuration has been changed in the kernel, it's asking us to reboot the system, which I'm going to do now, and which should be done generally in any case after you reinstall PiTrac. So I'm going to reboot and then come back and continue the installation in a minute. Okay, we have rebooted the Pi, we've logged back in, and the system should be up and running, at least with respect to our web server. As the documentation explains here, you can verify the installation in a few different ways. For instance, it's a PiTrac status that'll tell you what's going on. Right now we have the web server and the ActiveMQ broker, which is a messaging service both running. PiTrac is not running. Probably the easiest way to see if the services have started up, which they should have done immediately on reboot, is to just go to the PiTrac web port, and I'm going to show you how to do that. That is going to be the name of the the Pi, in this case RSP11, followed by colon and 8080, which is a port number. So I've just logged in to this Pi's web server, and the web server already has the interface for PiTrac up. You can see here there's some green lights for WS and MQ, which is the web server, and the active MQ services. C1 and C2, which are the processes for camera 1 and camera 2, are not currently running. We can start those in a moment, but before we do so, usually the first time I run a new PiTrac, I will go to the configuration user interface here, and I'll just do a couple of quick checks. First of all, under cameras, I want to make sure that the system has already detected the right cameras. In this case, it has the Animaker IMX296 mono cameras, so that looks good. Generally, we don't need to change anything in here, although I've noticed for a bright room, in some cases the camera 1 or camera 2 gain sometimes needs to be adjusted. In particular, the camera 1 gain, I think the default is 6, and often you'll need to bring it down to 1 or 2 to make sure that the images aren't too washed out. So finally, we're going to go to the logging interface, and I tend to select trace, which is not the default. Info is the default. I generally select trace when I first get started, just so I have a good idea of what's going on and have as much information as possible. So with this, if we go back up to, and of course you have to hit save changes if you change anything. At this point, I'm going to go back to the dashboard and see if we can start at the system. This usually takes about 30 seconds or so. The camera 2 will start up first, and then camera 1, and we are now at a point where both processes are running. The system is waiting for a ball, and at this point we can put a ball down in front of the system and hopefully it'll recognize it. There are a couple of other things. I'm going to hit stop here. The couple of other things you normally want to do once you've got the system running. Most importantly, you want to calibrate your system so that it understands where your lenses and cameras are set up and how they're set up. We will get more into the calibration process in another video.